1,000 stops per shift. That's the pace of a single New York City garbage truck. Its compactor crushing waste at 1,500 pounds per square inch through relentless stop-and-go traffic. Scale that across nearly 2,000 trucks moving 12,000 tons every day, and you're looking at the largest municipal sanitation fleet on Earth. What actually holds this operation together goes far beyond the trucks themselves. Every day, New York City produces enough waste to fill a football stadium by nightfall. Roughly 12,000 tons, collected and moved before most people finish their morning coffee. This is not just household trash. It's the combined output of 8 million residents, tens of thousands of businesses, and a constant churn of restaurants, offices, and construction sites. To handle this relentless tide, the Department of Sanitation deploys a fleet of nearly 2,000 collection trucks, more than any other city on the planet. Each truck is a custom-built workhorse, engineered for the city's dense grid and unpredictable traffic, and every one is part of a system that has been evolving since December 20, 1881, when the city's Board of Aldermen created the original Department of Street Cleaning. In the early years, horse-drawn wagons rumbled through narrow streets, their crews tasked with clearing ash and refuse that threatened public health. Today, the scale is almost unimaginable. DSNY's daily operation outpaces cities like Los Angeles and Tokyo, whose sanitation fleets are less than half the size. The modern fleet is not just large, it's diverse, with rear loaders dominating Manhattan's tight blocks and automated side loaders stretching through the outer boroughs. On any given weekday, these trucks will make thousands of stops, compacting waste under hydraulic pressures that rival industrial presses, and moving between 5 and 6 tons per vehicle per shift. The numbers alone reveal the stakes. Without this system, garbage would overwhelm sidewalks, block traffic, and trigger public health crises. Instead, a city of millions relies on a logistical choreography that begins before dawn, unfolds across 59 district garages, and ends only when every last ton has been routed to transfer stations or recycling centers. It's a scale that demands not just brute force, but precise coordination, because in New York, missing a single collection can mean chaos by the next morning. Manhattan's collection routes are mapped like a living circuit board. Every morning, 59 district garages coordinate the launch of trucks onto streets that rarely sleep. Each truck is assigned a list of nearly 1,000 stops, a figure that pushes the limits of both machine and crew. This is not a simple loop through a neighborhood. The city's routing software, built around a vehicle routing problem solver, recalculates paths every 15 minutes. Traffic accidents, construction, and even sudden surges in curbside trash can trigger dynamic rerouting. A single missed stop in Midtown can ripple through the system, delaying pickups for dozens of blocks. The process begins hours before sunrise. Garage supervisors review overnight data, traffic sensor feeds, waste generation forecasts, and curbside obstruction reports, feeding these into the routing engine. The software weighs every variable: truck capacity, crew shift limits, and the physical constraints of Manhattan's grid. Some streets require rear loaders that can squeeze into tight spaces. Others demand detours to avoid delivery trucks or blocked lanes. Each garage functions as a nerve center, dispatching and monitoring an average of 35 to 45 trucks per shift, each with its own real-time route updates. Fleet Operations Manager John Rivera describes the process as a game of inches and seconds. He explains, "You're not just moving a truck from point A to B. You're threading a needle 1,000 times a day, with every stop measured against the clock." The system's precision is relentless. If a compactor reaches 85% capacity before its planned unload, dispatch reroutes the truck to the nearest transfer station, then inserts a standby unit to fill the gap. This algorithmic choreography keeps the city's waste stream flowing, but it also creates punishing mechanical demands. Engines and hydraulic systems endure constant stop-and-go cycles. with every block adding to the stress that will soon be measured in fuel burn, heat, and wear. The moment a DSNY truck rolls up to the curb, the engine isn't just idling, it's poised for a sudden leap in workload. Under the hood, a diesel engine rated between 350 and 430 horsepower sits at the heart of the operation. These engines are tuned for high torque, delivering up to 2,200 pound-feet at low revolutions per minute, numbers more often seen in long-haul rigs than city vehicles. But the real transformation happens when the driver flips the PTO, power takeoff, switch. Instantly, engine revolutions per minute spike, and the PTO diverts rotational energy from the crankshaft to a hydraulic pump. This isn't just a background hum. It's a deliberate transfer of mechanical force into the compactor system. Mechanical engineer Dr. Linda Chen explains, "You'll hear the engine pitch change as soon as the PTO engages. That's the sound of the truck, generating the pressure needed to crush an entire block's worth of trash in seconds." The PTO delivers between 1,800 and 2,200 pound-feet of torque directly to the hydraulic pump, generating enough pressure to drive the compactor's ram through dense, unpredictable loads. Each engagement is brief, but intense, hundreds of times per shift, demanding a drivetrain built to withstand relentless bursts of stress. The audible surge in revolutions per minute isn't wasted energy. It's the pulse of a machine engineered to turn raw diesel power into the hydraulic muscle that keeps New York's waste moving, block by block. Inside the body of every DSNY truck, a hydraulic ram delivers the force of a small industrial press, 30 tons, focused on a wall of mixed waste. As the ram cycles, loose trash is compacted against a reinforced steel plate, reducing its volume by a factor of 4. What started as a sprawling, irregular heap is pressed into a dense, uniform block. This compaction not only maximizes each truck's payload, but also stabilizes the load for transport through miles of city streets. Mechanical engineer Dr. Linda Chen describes the process. "We're working with a 4-to-1 reduction. That means what would fill 4 trucks now fits in 1. The ram is powered by a hydraulic system running at 1,800 psi, with every stroke engineered to finish in under 10 seconds. When the truck reaches a transfer station, the unloading phase begins. Instead of tipping like a dump truck, a telescopic ejector panel, driven by its own hydraulic cylinder, pushes the compacted block out the rear. The ejector delivers a 30-ton force, clearing the body in less than 30 seconds. This system keeps the truck stable, prevents jams, and ensures a clean release every time. The entire mechanical cycle, from crushing to ejection, is designed for speed, reliability, and the relentless pace of New York's waste stream. Compaction inside a garbage truck is more than a matter of brute force. It triggers a chain of chemical and physical hazards that demand constant vigilance. As tons of mixed waste are crushed under 30 tons of hydraulic pressure, organic material breaks down and releases leachate, a corrosive, foul-smelling liquid that can reach up to 200 liters per truck per shift. In the heat of a New York summer, this fluid seeps through seams and collects beneath the compactor, eating away at steel and electrical fittings. Every drop must be contained and routed to sealed tanks, then treated at transfer stations under strict DSNY regulations. Failure to manage leachate risks both environmental fines and equipment corrosion that can take a $400,000 vehicle out of service. But the dangers don't end with liquid waste. Modern trucks face a growing threat from lithium-ion batteries hidden in curbside trash. When compacted, these cells can rupture and ignite, triggering fires inside the truck body. Between 2019 and 2023, DSNY recorded 4 fire incidents linked to battery thermal runaway. In one case, a side loader's suppression system activated in under 5 seconds, flooding the compactor with foam and preventing a total loss. Every truck now carries an onboard fire suppression kit, and drivers receive annual training in emergency shutdown and rapid response. These systems are not just add-ons, they are engineered lifelines, designed to contain hazards before they can spread beyond the steel walls of the truck. In a fleet that moves 12,000 tons daily, safety hardware is as essential as horsepower or hydraulic pressure. On the streets, the future of New York's waste collection rolls quietly. 7 electric trucks, each a $500,000 investment, now pilot routes in all 5 boroughs. These Mach-LR electric units promise zero tailpipe emissions and a 12% cut in fuel use along their assigned corridors. The difference is not just in the air. Where a diesel engine rattles at 80 decibels, the electric model glides by at 65 decibels, changing the soundscape for early risers and night shift workers alike. But the numbers tell a more complex story. Each electric truck costs $100,000 to $150,000 more than its diesel counterpart. And while the batteries deliver a 200-mile range, enough for a full shift, they can't yet double as snowplows or run back-to-back routes without hours on the charger. Efficiency gains show up in the details. On side loader routes, the electric drivetrain cuts dwell time at each stop to 15 seconds, compared to 30 seconds for some rear loaders. Yet for the crews, the work is as physical as ever. A veteran sanitation worker describes walking 8 to 12 miles per shift, regardless of what powers the truck. He recalls, "Doesn't matter if it's diesel or electric, we're still out there, block after block, lifting bags, making the city move." The technology is evolving, but the job's demands remain rooted in muscle, endurance, and the knowledge that every ton moved depends on human grit as much as machinery. The city's next chapter in waste collection will be shaped by both quiet motors and the steady rhythm of boots on concrete. 12,000 tons still arrive each day, each load a test of engineering, logistics, and human resolve. As cities grow and waste streams multiply, the system's limits become today's challenge, not tomorrow's. In the end, it's the worker who keeps the machine and the city moving. Share your thoughts below.